XTDB is an immutable SQL database built to simplify application development and data compliance. In my element trading shop, it is essential to track not just what was sold, but also the context of when and how changes were made to the data. So, from the last time that we looked at time travel, we see the orders for plutonium sales. These transactions recorded the amount sold across the first few days of 2025, with a correction for the second by changing the valid from date. Now, alternatively, instead of adding this for system time syntax to every table we query individually, we can instead just set the default system time. This acts as a way to apply the same system time to all queries contained within a single operation, such as across complex queries like joins or unions. An example would be setting the default time to January 3rd to see the previous state of the system with the incorrect amount of orders. Oh no, the space inspectors are back again. They've told me that our permit for plutonium transport has expired. To confirm this, let's check our permits table to see the most recent valid permit on the 5th. I'm not seeing any active permits, but when we actually check for the 4th, we'll see the one that expired at midnight last night. If you've noticed, I've also introduced a new by default hidden column, valid2, which will show us the expiration date of the permit. I've just gotten off the phone with Element Transports & Co. Thankfully, they've been able to issue me a new permit for the next month. So let me just set that up in my permits table. Now, when we run the same query again for the 5th, we can see the new valid permit, which is perfect. And if we want to see all the permits that have ever been valid, along with their starting and ending dates, well, we'll just query it for all valid time. Now let's see how we can utilize the final hidden column, system2, kind of similar to valid2. This shows us when data stop being visible by default within the history of our system, which I can demonstrate by using between. Specifying for the system time between these two dates, show us the resulting query. Finally, let's combine everything we've learned into one big single operation. Due to the size, I'm just going to paste the query. This query will give us a detailed view of each order alongside the permit that was valid for it at the time. By setting the default system time to all and the default valid time to the 4th of Jan, we can analyze the state of the data on this specific date while considering all system time changes across its history. We also use two final XTDB SQL operators, the first being nest1, which creates a nested column in our results. Instead of returning a flat structure, nest1 allows us to embed the permit details directly within each order as a single object. This is especially useful when there's a one-to-one relationship between orders and permits used. The second is overlaps, which checks for an overlap between specified time periods, such as each object's valid time. This combined approach makes it easy to track the full history of data, ensuring nothing is missed, allowing me unparalleled control over my shop's database. Thank you for joining me in this journey through XTDB's features. It's been a pleasure showcasing how this technology can transform data management, even in a humble element trading shop in the stars like my own.